So the first thing I actually want to review with you guys is I want to take a look at this stuff on the formula chart. So I handed that out to you if you didn't get one yesterday. And I specifically want to look at this section here. Okay, that's the section that we're talking about. Now, here, of course, this we're going to be dealing with today. This is our binomial probability formula. Okay, and so that would be the probability of getting exactly K successes out of N trials. And we'll practice that shortly. But I want to now, yesterday we referenced the difference in these three sets of means and standard deviations. And I'm going to tell you honestly, I don't think until this year did I just like totally 100% grasp those differences and make a conscious effort to tell my students and talk to my students about when to use what and such. So let's talk about those. This top one here, notice that the subscript is an X. So these are the mean and standard deviation for numbers of items in a particular sample. So they'll say out of a sample of 300, what is the mean and standard deviation for the number of books that have more than 100 pages? Okay, whatever. And this next set, you can see that the subscript is your p hat. So those are the mean and standard deviation of sample proportions. So meaning, if all of you guys got your proportion of time that you spend outdoors on a weekend and you all had your own individual p hats, then I would know, overall I would find the mean for the population of that, and I could find the standard deviation for those proportions. Okay. So but those are for proportions. Now, the third thing here, this is for sample means, and see the subscript on those are X bars. And so that's if you all had samples of 100 runs and how long it take y'all to run a mile. Those would be your sample means. And we would have a distribution of that, and we could compare yours to the population mean, and here is the standard deviation. Notice it's standard deviation over the square root of n. Okay. So there's a quick, hey, let's look at that formula chart and what those things really are. The other main thing that we talked about yesterday was the central limit theorem. Okay, so let's review that. So this thing called our central limit theorem is about the shape of the sampling distribution, and that's, made up of samples, okay, and the population. So central limit theorem is about the shape of the sampling distribution and the population. Okay, so our population, of course, is filled with individual items. And so we've got all of those individual items. We may or may not know the shape of it. Okay, we may or may not know the shape of the population. Okay, but we are going to drop down samples of size n. We will drop down samples of size n. They all have to be the same size, a particular sample size n. You can't give willy-nilly sample sizes, like one person picks a sample of size 100, one person does a sample of size 30, one person does a sample of size 50. They would all be the same size samples, so I would randomly pick that many items from the population, average it, and drop it down, and there is the sample average. Do that again, same size, average of that many, and average of that many, and so on and so forth. Technically, the central limit theorem only applies to means, okay, but we follow that kind of same thought process for proportions also. Technically, only applies to means. All right, now, let's say, we don't know what this is, so I'm just going to kind of draw it something funky. What would be the mean of this is, the mean of the population is mu. And the standard deviation of the population is sigma. But when we drop down our samples, these are sample means. And those have new formulas from our formula chart right here. These other page over. That's these. Our sample means. Okay, our formulas. So do you see how they have, there's the mean of those sample means, and there's the standard deviation of those sample means. All right, we're just about done with this discussion, and then we'll go on to some actual problems. So what's our central limit theorem say? Central limit theorem is about the shape of the sampling distribution and the population. Central limit theorem is about the shape of the sampling distribution and the population. Okay, here's the next thing. If n is large enough, it doesn't matter the shape of the population. The sampling distribution will be normal. Okay? And then you go back to the main thing. So that's the key. If n is large enough, and for means, what's large enough? Greater than or equal to 30. For proportions, which technically don't, aren't the central limit theorem, but what is our large enough for proportions? NP, and n times 1 minus p, so our number of successes and our number of failures need to be at least 10. Okay, good. And so then this one has the mean of the sample means is the same thing as up there. Tell me about the standard deviation here. It's always going to be what compared to the population? Compare this down here, compare this standard deviation to the population standard deviation. It will always be what? Smaller. Why will it always be smaller? Why is it less varied? We're dividing by the square root of n. So that standard deviation of these means will always be smaller than the population standard deviation. Okay. Now, last thing before we go on and I'll let you guys start doing your work where I walk around and I help you. I want us to have a little discussion about this binomial stuff, binomial PDF, binomial CDF, and that kind of such. So by doing that, I want to do that through looking at problem 5 on page 84. So turn on over. Now, if you were here yesterday, we did this problem, okay? But it doesn't hurt to kind of look at it. This is just an excellent problem because all of those answer choices one of them gives x is greater than 10, x is less than 10, one gives x is at most 10, and one of them gives at least 10. So these 5 answers give the whole gamut of possibilities of how to represent things with the formula. Okay, so let's take a look at it. A 12-sided die, so we know that there are evenly or fair die. There were numbered 1 to 12. Which of the following gives a probability that you get at least 10 threes out of 50 rolls? Okay, so what is our n in this case? Nope, 50 is the sample size. 50 is our n. What's the probability of getting a 3? 1/12, which is 0.083. Okay, and we want to find the probability of getting at least 10. Okay, so remember with these, our calculator is kind of persnickety and won't necessarily do everything for us, so we have to keep in mind the sequence of what we want and don't want. So 0, 1, 2, up to what we're doing here. Okay, if that is the sequence of numbers of successes, what part do we want if we want at least 10? We want at least 10. What part of that is it? Okay, at least 10 is, so this is the section that I want. And if you weren't here yesterday, we had a big discussion about how your calculator cannot compute from a midpoint up to the end. Calculator doesn't do that. It will only compute the bottom part. So how can I get this top part if my calculator only gives me this bottom part? Good. So I'll do 1 minus this bottom part. And this is an accumulation. So I will binomial accumulate out of 50 trials, and 1/12 is my probability. I will do up to, I will take off what part? Up to and including what? Will I take off? I will take off the bottom 9. If you put the number 10 here, you've taken off too much. Okay, so with that being said, let's answer what each of these multiple choice questions shows us, and then we'll go to the assignment for today. What probability is A giving us? A is showing the sequences of getting the probability for what? Good. It goes 0 to 9. That's x is less than 10. Good. Okay, B. So B is showing us the probability. So look at what it's showing us. 11 on up to 50. So what is that showing us? Greater than 10. So your answers, I want it to be all in terms of 10. Okay. So this one is showing greater than 10. Oops, x is greater than 10. Okay, this is an interesting one, this next one. 1 minus 0 up to 10. So you are taking off the bottom 10. What's this one showing us? Yeah, it's showing us the exact same thing as part B. So it's interesting that these two are shown in two different ways, but they mean the same thing. You can either straight up go 11 to 50 or 1 minus the bottom 10. Those both show the same thing. Okay, D shows 1 minus the bottom 9. Taking off the bottom 9 means I will be finding the probability that x is what? 10 and up. And 10 and more up is at least 10. Okay, look at E. 0 up to 10. So it's finding the probability of 10 and below. Not just straight up less than 10, but less than or equal to 10. Or at most 10. Okay, so I like this problem because it shows all the different ways that you can do the greater than, the less than, the at least, the at most, and it even gives you one that's shown in two different ways. So that's just an excellent problem. So let's go ahead, go on over to our assignment for the day, and I'm going to do the first problem with you. You will be working today. By the way, if you weren't here yesterday, we worked on pages 83 to 85 or something, and if you wanted more practice and you're just feeling real apprehensive about these, there's answer keys to some of those practice problems. But we're going to start on page 100 here. And so your assignment is going to be pages 100 to 109. And it's the multiple choice part of this. So I took off the quiz for today. That was over part 3. So I'm nixing that. However, I don't know if you're like me, but I'm at my wit's end. I'm getting really done with stuff. So I kind of need some motivation if I got to push myself to do something. I really want to push you guys to make sure that you take the probability section seriously. So there is a probability quiz over parts 4 and 5 on Wednesday. Okay, next Wednesday. And that'll probably be our last quiz, by the way. But I just kind of need to give you that little carrot out there that I need you to really focus on this. And we're going to practice all the rest of the class period. We'll have a solid 30 minutes today in class. But let's do number 1 together. Here we go. Suppose that x is a binomial random variable that counts the number of successes in 30 trials. Find the probability that x is greater than 1 if the probability of success for a single trial is 0.14. All right, I want to first put up here what AP testers need to show for their work on a free response question. So if you are an AP tester, this is the work if this was a free response question you would have to show. The probability that x is greater than 1 equals. And what I'm going to be doing is filling in this formula in the sequence from the lowest part of the sequence to the upper part of the sequence. So I'm going to do the lower bound to the upper bound. So if I want to go greater than 1, what's the lower amount of successes that I need? How many? 2. Good. So my first in my sequence is 30, choose 2 successes. No fraction bar there. 30, choose 2 successes. And then the probability of success to the number of successes. So 0.14 to the second power. And next comes probability of the failure, which would be 0.86 to the number of failures that you would have. And that would be 28 because there's 30 items total. 2 of them were successes, so 28 are failures. That's the first part of the sequence that we want. Plus, dot, 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 plus, now let's do the last part of the sequence. Since we're going greater than 1, what's the highest part of our sequence? 30 successes. So we got 30, choose 30 successes. And then I got 0.14 to the what? 30 successes. Which means 0.86 is to the how many successes? None of those. And so that is the work that you would have to show on a free response problem. Now, the AP test does not care about calculator speak. So writing out what your answer is, writing it out in calculator format gets you nothing. Okay, it has to be that. But let's go ahead for everybody else. Put how you do this in your calculator just because we need to know that. How would I calculate this? In my calculator, everything, take off. What part am I taking off? Yeah, I'm taking off 0 and 1. I want 2 to 30. So I have to take off 0 and 1. Okay? So it's everything, take away binomial CDF of 30, comma, 0.14, comma, what am I taking off? What number goes here? 1 or 2? 1. If you put a 2 there, you've taken off too much. Haha. Okay, so running that in your calculator, it's under second bars. And you go down to, it's in where the norm CDF stuff is, but it's, you go down the way to the bottom. That should come out to that number right there. Okay? All right, so your assignment then is to work on 100 to 109, and you've got a solid 30 minutes. See, there's our lunch bell. 30 minutes that I'm coming around and helping you with the whole time, so you got to be working, no phones out.